Just 3 years after I started working here, I get to fly in a plane with motors that we built and tested. Like, there's very few engineers that get to design and build something from scratch and get to go up and try what they've built. Where else are you gonna get that? Such a change from a few weeks ago, man.
Yeah, no, it's just empty, really.
Biomimicry is when we take something from nature and we build something or we design something that uses the features from nature. So for example, aircraft wings have a shape that mimics fish or dolphin because they're very aerodynamic. Other things that we could say biomimicry, like trees or spider webs, are very strong, and so we can mimic those types of structures in human-built structures. Electric motors, they're much easier to control, and they're much higher efficiency than combustion engines, gas turbine or piston engines.
Nuts.
It's the type design motor, and it's the first time we're gonna fly with it. Has a bunch of hours on all sorts of torture stands, but this is where we get to experience the performance. We can unleash Aaliyah finally.
We're putting the Gen 6 pusher on, finishing up the wiring, and doing cowling fit up next. We'll be climbing like a banshee.
That's technical term for climbing fast. It's the highest power density motor that we know of for an aircraft. It's the highest power density motor that we've made. It's air-cooled direct drive, so it's very simple, very robust. It's got very high efficiency, so we're targeting 98% in cruise. It also can fly in the rain because it has an inertial particle separator, which is here. And we are going to orient the drain hole to be on the bottom.
This motor, the Gen 6 motor, is going to put out something like 25% more torque than the Gen 4 that we've been flying with. So we're looking at a significant power increase, which is going to shorten our takeoff distance, increase our climb rates, basically be a rocket ship. A lot of the cool stuff here is not super visible, like all the controls are running self-sensing controls, so we can run without an encoder. In the past, we've had to replace encoders, and so we're adding additional robustness there by taking something away. This is as representative of our cert design motor as we're going to get with engineering units. So this is probably the motor that's going to be on the plane until we put a cert motor on the plane. It's kind of like our final exam. There's one thing to look at all the numbers in the book, right? It's great to look at CAD and understand by the book what the numbers mean. There's kind of something unspoken about going and sitting in the plane and actually getting a feel for it. Looking at time series plots from flight test is great for knowing analytically what's happening, but really to develop that feel for, hey, is this too much performance? Is it not enough performance? Is it the rocket ship that we think it is? The only way to really do that is to go and sit in the plane.
It's going to be a pretty standard takeoff profile, initial checks, then initiate first climb up to safe altitude.
It generally supports that same weather with calm winds greater than 6 and clear skies.
It's all about the application, the weight and the size of the motor, and as simple as you can make it so that it's reliable because it's going to fly.
Tell me that you're ready, and then tell me that you're ready.
Nature has evolved in a really optimized way. There's no difference between evolution in nature and evolution of designs. It's exactly the same laws, and nature follows the laws of physics pretty well, and engineering designs need to follow the same laws of physics.
All right, here we go. Here comes power. Uphold the brakes. Thrust is set.
Yep.
Oh, see, that's so much nicer.
Like that?
Yeah, rudder's in the hand.
We've poured blood, sweat, and tears into getting to this point, and now we're finally there where we have a kick-ass motor that we can certify.
This is nice. 60.
We're at a point where the hard work is finally paying off in a demonstrable, measurable way.
Holy crap, here we go.
We're out of the lab, so we're not living in a laboratory or papers or research world. We can fly with these motors cross-country already, making aircrafts and selling aircrafts with these propulsion systems on, like that's real. This is how in 4 years we are making some of the best motors in the industry. Just 3 years after I started working here, I get to fly in a plane with motors that we built and tested. Like there's very few engineers that get to design and build something from scratch and get to go up and try what they've built. Where else are you gonna get that?